Number 62. Name several important airspeed limitations not marked on the face of the airspeed indicator. VA, the designing maneuvering speed. The maximum speed at which the structural design's limit load can be imposed, either by gusts or full deflection of the control surfaces, without causing structural damage. Note, operating at or below VA does not provide structural protection against multiple full control inputs in one axis or full control inputs in more than one axis at the same time. Landing gear operating speed, which is VLO. The maximum speed for extending or retracting the landing gear if using aircraft equipped with retractable landing gear. Also, the VX speed, best angle of climb. It was important when a short field takeoff to clear an obstacle is required. And the VY speed, best rate of climb speed, which the airspeed will give the pilot the most altitude in a given period of time. Number 63. What airspeed limitations apply to the color-coded marking system of the airspeed indicator? The white arc is the flap operating range. The lower limit white arc, the VSO, is the stall speed landing configuration. The upper limit white arc is the VFE, the maximum flap extension speed. The green arc is normal operating range. The lower limit green arc is the stall speed clean or specified configuration, and the upper limit green arc is the normal operating speed, VNO, or maximum structural cruising speed. The yellow arc is the caution range, operations in smooth air only, and the red line is VNE, never exceed speed. Above this speed, structural failure may occur. Number 64. How does the vertical speed indicator work? The vertical speed indicator is a pressure differential instrument. Inside the instrument case is an aneroid, very much like the one in an airspeed indicator. Both the inside of this aneroid and the inside of the instrument case are vented to the static system, but the case is vented through a calibrated orifice that causes the pressure inside the case to change more slowly than the pressure inside the aneroid. As the aircraft ascends, the static pressure becomes lower and the pressure inside the case compresses the aneroid, moving the pointer upward, showing a climb and indicating the number of feet per minute the aircraft is ascending. Number 65. What are the limitations of the vertical speed indicator? The VSI is not accurate until the aircraft is stabilized. Because of the restricted airflow to the static line, a 6 to 9 second lag is required to equalize or stabilize the pressures. Sudden or abrupt changes in aircraft attitude will cause erroneous instrument readings as airflow fluctuates over the static port. Both rough control technique and turbulent air result in unreliable needle indications. Number 66. What instruments contain gyroscopes? A turn coordinator, the heading coordinator or directional gyro, the attitude indicator, or artificial horizon. Number 67. What are two fundamental properties of a gyroscope? Number 1 is the rigidity in space. A gyroscope remains in a fixed position in the plane in which it is spinning. And number 2 is precession. The tilting or turning of a gyro in response to a deflective force. The reaction to this force does not occur at the point where it was applied. Rather, it occurs at a point that is 90 degrees later in the direction of rotation. The rate at which the gyro precesses is inversely proportional to the speed of the rotor and proportional to the deflective force. Number 68. What are the various power sources that may be used to power the gyroscopic instruments in an airplane? In some airplanes, all the gyros are vacuum, pressure, or electrically operated. In others, vacuum or pressure systems provide the power for the heading and attitude indicators, while the electrical system provides the power for the turn coordinator. Most airplanes have at least two sources of power to ensure at least one source of bank information if one power source fails. 69. How does the vacuum system operate? An engine-driven vacuum pump provides suction, which pulls air from the instrument case. Normal pressure entering the case is directed against rotor vanes to turn the rotor gyro at high speed, much like a water wheel or turbine operates. Air is drawn into the instrument through a filter from the cockpit and eventually vented outside. Vacuum values vary between manufacturers, usually between 4.5 and 5.5 in Hgs, but provide rotor speeds from 8,000 to 18,000 RPMs. Number 70. How does the attitude indicator work? The gyro in the attitude indicator is mounted on a horizontal plane and depends upon rigidity and space for its operation. The horizontal bar represents the true horizon. This bar is fixed to the gyro and remains in a horizontal plane as the airplane is pitched or banked about its lateral or longitudinal axis, indicating the attitude of the airplane relative to the true horizon. Number 71. What are the limitations of an attitude indicator? The pitch and bank limits depend upon the make and model of the instrument. Limits in the banking plane are usually from 100 degrees to 110 degrees, and the pitch limits are usually from 60 to 70 degrees. If either limit is exceeded, the instrument will tumble or spill and will give incorrect indications until reset. A number of modern attitude indicators will not tumble. Question 72. What are the errors of the attitude indicator? Attitude indicators are free from most errors, but depending upon the speed with which the system functions, there may be a slight nose-up indication during a rapid acceleration and a nose-down indication during a rapid deceleration. There is also a possibility of small bank angle and pitch error after a 180-degree turn. These inherent errors are small and correct themselves within a minute or so after returning to straight and level flight. 73. How does the heading indicator operate? The operation of the heading indicator uses the principle of rigidity in space. The rotor turns in a vertical plane, and the compass card is fixed to the rotor. Since the rotor remains rigid in space, the points on the card hold the same position in space relative to the vertical plane. As the instrument case and the airplane revolve around the vertical axis, the card provides clear and accurate heading information. 74. What are the limitations of the heading indicator? The bank and pitch limits of the heading indicator vary with the particular design and make of instrument. On some heading indicators found in light airplanes, the limits are approximately 55 degrees of pitch and 55 degrees of bank. With either of these attitude limits is exceeded, the instrument tumbles or spills and no longer gives a correct indication until reset. After spilling, it may be reset with the caging knob. Many of the modern instruments used are designed in such a manner that they will not tumble. 75. What error is the heading indicator subject to? Because of precession, caused chiefly by friction, the heading indicator will creep or drift from a heading to which it is set. Among other factors, the amount of drift depends largely upon the condition of the instrument. The heading indicator may indicate as much as a 15-degree error per every hour of operation. 76. How does the turn coordinator operate? The turn part of the instrument uses precession to indicate direction and approximate rate of turn. A gyro reacts by trying to move in reaction to the force applied, thus moving the needle to miniature aircraft in proportion to the rate of turn. The slip skid indicator is a liquid-filled tube with a ball that reacts to centrifugal force and gravity. 77. What information does the turn coordinator provide? The turn coordinator shows the yaw and roll of the aircraft around the vertical and longitudinal axes. The miniature airplane will indicate direction of the turn as well as rate of turn. When aligned with the turn index, it represents a standard rate turn of 3 degrees per second. The inclinometer of the turn coordinator indicates the coordination of aileron and rudder. The ball indicates whether the airplane is in coordinated flight or is in a slip or skid. Number 78. What will the turn indicator indicate when an aircraft is in a skidding or slipping turn? For a slip, the ball in the tube will be on the inside of the turn, not enough rate of turn for the amount of bank, and if it's a skid, the ball in the tube will be to the outside of the turn, so too much rate of turn for the amount of bank. How does the magnetic compass work? Magnetized needles fastened to a float assembly around which is mounted a compass card align themselves parallel to the Earth's lines of magnetic force. The float assembly is housed in a bowl filled with acid-free white kerosene. Number 80. What limitations does the magnetic compass have? The jewel and pivot type mounting allows the float freedom to rotate and tilt up to the approximately 18-degree angle of bank. At steeper bank angles, the compass indications are erratic and unpredictable. 81. What are the various compass errors? There's like a handful. All right. Oscillation error is the erratic movement of the compass card caused by turbulence or rough control technique. Deviation error is due to electrical and magnetic disturbances in the aircraft. Variation error is angular difference between true and magnetic north, referencing isogenic lines of variation. The dip errors are the acceleration error. So on east or west headings, while accelerating, the magnetic compass shows a turn to the north, and when decelerating, it shows a turn to the south. Remember ANDS, ANDS, accelerate north, decelerate south. Another dip error is the northerly turning error. The compass leads in the south half of a turn and lags in the north half of a turn. For that one, remember UNOS, UNOS, undershoot north, overshoot south. Number 82. Describe the function of the following avionics equipment acronyms. AHRS, Attitude and Heading Reference System. It's composed of 3-axis sensors that provide heading, attitude, and yaw information for aircraft. It's designed to replace traditional mechanical gyroscopic flight instruments and provide superior reliability and accuracy. ADC is Air Data Computer, aircraft computer that receives and processes pitot pressure, static pressure, and temperature to calculate precise altitude, indicated airspeed, true airspeed, vertical airspeed, and air temperature. PFD is the primary flight display, a display that provides increased situational awareness to the pilot by replacing the traditional 6 instruments with an easy to